Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. This is a problem that was asked in a high school math test, and this is not a trivial problem, and there might be many different ways to solve this, but I'll show one way which may be interesting, unique, and may not be a very conventional approach. So in the problem, we are given that x multiplied by x squared minus 1 multiplied by x cubed plus 1 is equal to minus 1. What is the value of x to the power 8 plus x to the power 7? Now, from the equation that we are given in terms of x, and that really involves, high exponents like 5 or 6, which is really, difficult to solve if you're considering to obtain a value from x from what's given and then, substituting that in the expression that you're asked to evaluate, which also involves, these higher powers, x to the power 8 plus x to the power 7. So one approach is to basically try to factorize this expression. And this might be a little bit harder than it looks, but we can try by adding and subtracting terms so that we get some common factors or commonality. And that is one technique that might be useful in some problems. So in this case, what I do is I start with x to the power 8 plus x to the power 7, and then I add some terms. For example, here I have added, the first term that I have added is x to the power 6. So I have x to the power 8 plus x to the power 7 plus x to the power 6. So I have basically, the powers of x in descending order here, right? So if I added x to the power 6, I need to subtract x to the power 6. So I do that. But while I'm subtracting, I also add negative x to the power 5 and negative x to the power 4. So I maintain the same order of descending powers or descending exponents of x, right? And then I have to add back x to the power 5 and x to the power 4 to maintain parity. And again, to maintain the descending order, I add x cubed. So the next set of terms I end up with is x to the power 5 plus x to the power 4 plus x to the power 3. Now, to maintain parity, I need to subtract x cubed. So I subtract that. But then I again add to this negative x squared and negative x. So I have the same order of descending exponents of x. And then I add back x squared plus x. I have added a 1, so I subtract 1. So this is all, comes down to the simple, two-term expression x to the power 8 plus x to the power 7, but I have expanded it out and sort of, arranged it in descending powers, right? Descending exponents of x, and try to see whether I can come up with something from here in terms of, creating some factorization of this. So if I take x to the power 6 common from the first three, then I am left within parentheses x squared plus x plus 1. From the second set of those three terms, negative x to the power 6 minus x to the power 5 minus x to the power 4. If I take minus x to the power 4 common, then again within parentheses I have x squared plus x plus 1. So note that the terms within parentheses are same. Then from the third set, x to the power 5 plus x to the power 4 plus x cube. I take x cube as common, and again I'm left with x squared plus x plus 1 within parentheses. And then from the set of minus x cube minus x squared minus x, if I take negative x common, again within parentheses I have x squared plus x plus 1, and then finally I have x squared plus x plus 1 minus 1. Now, leaving the minus 1, it's very easy to see that from all of the rest of the terms we have, we can take x squared plus x plus 1 as common, right? And if we do that, this is what it comes out to be. X squared plus x plus 1 multiplied by x to the power 6 minus x to the power 4 plus x cubed minus x plus 1, and then we have still the negative 1 at the end, right? So we have to look in that second term, the one with the higher powers or higher exponents of x, to see what we can do there, right? Well, we can take from the first two of those x to the power 4 common. So we have x to the power 4 multiplied by x squared minus 1. And from the following two, x cubed minus x, we take x common. So we have x, and then within the parentheses we have x squared minus 1. And then from here on, we basically take x squared minus 1 as common. Then for the second term within parentheses, we are left with x squared minus 1 multiplied by x to the power 4 plus x plus 1. And this can be further written as x squared plus x plus 1 multiplied by, within parentheses, we have x squared minus 1 multiplied by x. So we are taking x common from x to the power 4 plus x, right? And so within the parentheses, we have x cubed plus 1 once we take x common, right? And then this further comes to x squared plus x plus 1 multiplied by, within parentheses, we have x multiplied by x squared minus 1 multiplied by x cubed plus 1 plus 1, and then of course there's a negative 1 at the end outside. So I've highlighted the terms in red because those match up with what we have been given, which is x multiplied by x squared minus 1 multiplied by x cubed plus 1 is equal to minus 1. So for those terms in red, we can just substitute negative 1. And once we do that, the expression within the second parenthesis, that becomes 0. So we basically have 0 minus 1 is equal to minus 1. So after some thinking and some attempts, I was able to figure out this path to the problem, which is unconventional, but this can give you a pretty quick and easy solution. Now, there might be other ways of approaching this problem which might be more time consuming and more laborious, but hopefully this was an interesting way of how to solve this particular problem.